Hi there guys, I'd like to welcome you once again along on one of my prehistoric road trips, and I decided to call this one the Jurassic road trip because I brought you to the Jurassic coastline here on the south coast of England. The reason being is I wanted to see if I could try and explain something called the Cretaceous period, and the reason for that is because following on from this, I'm going to go on down to somewhere called the Solent, which is one of the ancient river systems that used to lie in England. And well, basically over 15,000 stone artifacts were recovered from along the Solent, and this really helps us to see that it was an important place for ancient people in their first footsteps on what we didn't know as the British soils, the British mainland. Now, I do have a bit of a problem because the Cretaceous period runs into the Jurassic period, which runs into the Triassic period, and all them shunted together are called the Mosaic period, which is from 250 million years ago until about 66 million years ago. Only that leaves me with a brand new problem. The problem being this: we live on a planet which is 4.5 billion years old, so I've got a clump of time, meaning around about 4 billion years unaccounted for. And so I decided I'd have a go at telling you about the 4.5 billion years, and it's going to take a little bit of getting your head round. So if you don't mind, bear with me and let's unroll a fantastic, fascinating story. Well guys, what I would like you to remember is that this is going to be quite a difficult story to tell, in one sense of the word, and for yourself, I want you to remember it's important not to try and remember the names of all the times of period or the times of period, because that will get confusing and make your own brain ache. But let's start off by looking back at where things all began. So to do that, we need to recognise we're in a universe which is 15 billion years old, and around about 5 billion years ago, the sun was sitting in the universe, and in orbit to the sun there was an extraordinarily large amount of space dust, and this began to accumulate and stick together until it formed a massive great big ball of dust. But it was hot, it was molten, there was no oxygen, and it was completely devoid of any life, and was continually being bombarded by other giant rocks from outer space. One particular one actually became what we now know as the moon. So that took up about 500 million years, and that was what we know as the Hadean period. So next, what we need to do is we need to have a look at something called the Atrium Period. And the Atrium Period was a time where less rocks were hitting the planet, and it became a little bit more stable, although the Earth was spinning at such high speed that a day only took 3 hours to complete. and the moon was extraordinarily close, so any water that was on the planet was completely, you know, it was unstable. And pretty much the whole Earth was just covered in water with a crust forming. To begin to look at a piece of land coming to the surface, you've got to start thinking volcanic and seeing volcanic eruptions coming out of the sea and beginning to create what you could consider to be the very first Earth mass above sea level. Not a place for a summer holiday, mind you. And remember that actually lasted 1.5 million years, which brings us to a point where we're 2.5 million years away from where we are now. And then from the sky once again came raining down meteorites, which were carrying minerals which went to the bottom of the sea, and there started organic activity, and these flumes were rising up from the bottom of the sea, carrying carbon dioxide into the sky. This was all falling, coming back down into the water, and there was a particular, couldn't call it a plant, but there was this growth, that one there. This is known as a stromatolite. I can't tell you how cold it is. It's the 4th of January, the wind is biting, so I'm going up to explore whether this cave is any good, and if it is, I'll carry on telling you the story from in there. I managed to find myself a little cave. It was becoming slightly worse for weather out there, and this feels a bit like home anyway, just for now, to try and tell you a bit more of this story. So the Atrium Period, lasting 1.5 million years, brought us to the Protozoic Period, and I'll let you guess what that is. It's when things became, photosynthesis began. Up till this point in time, we'd had no life on the planet whatsoever, just water and rock, and tectonic plates shifting about as well, moving into different land masses, and so life began, did it? Well, really, what you've got is single cell organisms, right? But it was a beginning, and it lasted for about 2 billion years. At this point in time, all of the tectonic plates were moving, and they all became connected together, and all of the land that's now separated joined up, and this is called Rodinia. But basically, you got one massive continent, and the rest of the planet is sea. So what have we done now? We've come through the Hadean Period, lasting 500 million years. Then we've gone into the Archean Period, lasting 1.5 billion years. Then we've come into the Protozoic, lasting 4 billion years. So that's a staggering 4 billion years of time, and now oxygen levels are starting to rise, and we have single cell organisms, and then, well, it just would, wouldn't it? The planet began to freeze over, which was what's known as probably the thickest and deepest ice age known of all time. It lasted 150 million years, and the ice was 10,000 feet thick. So for 150 million years, some people describe it as a snowball effect, we were a ball of ice orbiting the sun, and basically we were reflecting the sun's heat, so nothing was changing. So what could change? We were kind of doomed, really. We were floating through outer space as an ice age. Well, you've got to remember that in the middle of the Earth, even though it was surrounded in ice, it was a basically molten ball of fire. And so once again, volcanoes came to the rescue, and they broke through the ice, billowing fire and smoke, and basically choked the atmosphere around the earth, and we were stopped reflecting the sun, and then things began to thaw. And it was in that big thaw that everything began to change. The single cell organisms became more complex, and then we started seeing small microbial plant life and little complex critters moving around. So you're starting to see little things like trilobites, and you're starting to see things like little tiny fishes, and but things are beginning to progress forward. And as you know, when the fish come out onto land, you're first of all using their fins and then growing little legs, and this turns into the dinosaurs. And with just 550 million years left to go, we bump into the Paleozoic, and then we bump into the Mesozoic. So the oldest, the Triassic period, started 252 million years ago, and it went up to 201 million years ago, bumping into the Jurassic period, and the Jurassic lasted till 145 million years ago, and then we end up in the early Cretaceous, which is 145 million years ago to 66 million years ago. So at the end of the Jurassic period, sea levels began to fall, and forests began to grow, and they fell, and then you ended up getting lagoons and lakes and rivers. And this period started to interfold all of these sediments together, and this is where you get, and then we end up with tectonic plates which are moving once again and shifting into each other. Here, look, this is a great example of what I'm talking about. Imagine that. They're just being pushed straight up as they squidge as the land rises up. And then Rodinia began to break up as once again the tectonic plates began to move, and as they separated, given us separate continents, bumping into each other once again, where you're forming things like Mount Everest as two continents collide. Basically a kaleidoscope of moving plates, and it's not an easy story to tell. I hope your head's not feeling too bad so far. So it's during this Cretaceous period that I need to take you down deep underneath the sea and look at the coral reef beds, because this is where the formation of the flint began, and the stuff that became the stone tools. So what you have is you have a coral reef system which wears its skeleton on the outside of its body, called exoskeletal matter, and over millions of years, as that coral reef sits there, it ends up sitting in its own the breakdown of itself, which is silicate rich. It's its own compost ground. Even though it's healthy at the top, what's growing underneath, the sediments of the coral reef system, are becoming the flint. So even we're in today's world, where you've got coral reefs, what you've got is you've got flint being formed for millions of years' time in the future. And that's quite helpful all by itself to know. Anyway, the Cretaceous period, it did come to an end once again with a visitor from outer space, another giant rock 7 miles wide, landed in the Gulf of Mexico and completely decimated everything that was living on the face of the planet. And that would have taken quite a few million years for things to begin to recover. Everything, the whole planet, all of the Earth was covered in the sea from the impact of that colossal great big meteorite, and it moves us into a new time, a time where things started to begin to look a little bit more like the Earth as we know it today. What changed? Mammals. Little things that burrow underground. They were the only survivors because they were underground, and out they came, and they began to move around. Little tails, 4 legs, long pointy noses, and it wasn't long before they began to evolve, started climbing trees, and you had some of your very early monkeys and bits and pieces like that, basically living in the trees. And then something dramatic happened at one particular point on Earth in Africa. The plates were beginning to rise as they were budging into each other, and it's known as a rift, and it was on the west coast of Africa. And what it began to do is it began to create the area that was lush and green was beginning to become starved of water, and it began to dry out and become arid, and what was comfortable for the monkeys as they knew their life was becoming somewhat harsher, and they had to come down from the trees, which is a pretty dangerous thing to do, and that was the reason they were up the tree, because there's a lot of things clambering around on the face of the planet that wanted to eat them. And it stands to reason that if you stand up, you can move faster, you can see across the long grasses, and you can get about a bit more. And the word bipedal begins to form, and the great line of hominids, and I'm not going to even try to explain that, not on this occasion anyway, I've already probably done your head in, begins to evolve, and they begin to migrate and move around the planet. Only what they didn't know is there was another ice age coming to get them. And around about 40,000 years ago, it was descending from the North Pole, and it came right down, right across Europe, freezing everywhere, driving people completely off of Britain, because people had already been here, not our Homo sapiens species, but predecessors. And the ones I've come here to talk about actually, Homo heidelbergensis, Homo erectus, and Homo, can't remember the name, my head's done in. But and this lasted right up until about 14,000 years ago, when it began to retreat, and once again we could move back onto the British soils, and it kind of brings us up to date to where we are now. We just had the short Mesolithic period, the Neolithic period, which turned into the Copper period, the Chalcolithic, and the Bronze Age, and the Iron Age, and the Industrial Revolutions, and all of the Victorians and the Georgians and everything like that, and up to date. Anyway, I hope that wasn't as bad as it felt like it was. And you're welcome to write me letters of complaint, hate mail, or even death threats. But that is in a nutshell the history of the Earth.